Welcome back to the deep dive. So for the last few sessions, we've been deep in the weeds of structure,
Very deep.
figuring out how to build that scaffolding with groups, subgroups, and projects. We've basically mapped out the geography,
Right.
but now we have to actually populate that world. So today, we're shifting focus entirely to the human element, the participants.
And that structural framework you just spent all that time building is, well, frankly, it's just an invitation for chaos if you don't master the permission flow. This is really where security meets administrative efficiency. For you, the listener, whether you're managing 3 teams or, 30, this part is essential.
It's everything.
It's all about who gets access and, critically, what they can actually do once they're inside.
And the core concept we really need to master right away is the engine that drives all of this, for better or for worse. Inheritance.
Yeah.
We mentioned the term, but we need to see how it dictates everything. So what is being inherited, and how does that process fundamentally work through the structure we built?
The easiest, most reliable mental model is that GitLab permissions, they flow downhill.
Downhill.
Always. Think of it like a river. Everything starts at the highest point, and gravity, or inheritance in this case, pulls it down through every valley, every stream below it.
I like that analogy because it's so simple, but it explains so much of the complexity that can happen.
It's the governing principle for scaling. So rule number 1, permissions are tied directly to the structural containers, the group, the subgroup, and the project.
Okay.
If you grant a user a specific role, let's say the developer role, at a high-level container, that user automatically inherits that exact same role for every single subgroup and every project nested underneath it.
And this is where the efficiency gains are just massive.
Totally.
You avoid that soul-crushing administrative redundancy. Let's bring back our Acme Corp test case. Acme Corp is the main top-level group.
Right.
And underneath, we have dozens of subgroups like billing, marketing, R&D, and each of those has tons of projects.
So if you bring in a new team member and you assign them the developer role to that top-level Acme Corp group,
Just one click.
one click, and you have instantly provisioned their access to the code, the issues, the wiki, all the relevant features across literally every single repository in the entire organization.
So that single action, clicking Add Member, just one time, could save an administrator from sending 30, 40, maybe 70 individual invitations.
Oh, easily. That cascading inheritance is the key to managing users effectively across a massive, complex structure. It's elegant.
It is elegant, but that elegance comes with a pretty big warning label, doesn't it?
It does. This is where that simple rule becomes a major operational gotcha.
Okay.
So say you accidentally create a new highly confidential project, maybe the plans for internal finance systems or some executive compensation data.
Right. Sensitive stuff.
And you forget to place it in its own restricted group. You accidentally nest it under the main wide access Acme Corp group.
Uh-oh. Because the permissions flow downhill.
Every single user who was previously granted access to Acme Corp as a developer, or even a reporter or a guest, now automatically inherits access to that confidential financial data too.
Wow.
Inheritance is indiscriminate. If the structure allows it, the permissions will follow. This is exactly why architecture and participant management are inseparable.
That immediately raises the stakes. So if you're managing a sprawling structure, inheritance is your best friend for efficiency, but it's a terrifying security risk if your structure isn't pristine.
Precisely.
So now that we know how people get in, let's define what they can actually do. We need to break down those specific access levels, the roles, moving from the least capability up to the highest authority.
Yeah, and defining these 5 core roles is where we move from just structural access to actual, functional capability. These roles tell the system, what kind of work is this person allowed to do?
Okay, so let's start with the person who is just observing, maybe an external consultant or a stakeholder who just needs to follow along without getting their hands dirty.
That's the guest role.
Yeah.
This is the least privileged access level. It's primarily read-only.
Read-only.
A guest can view issues, they can comment on them, they can browse basic project info, but crucially, they cannot push code, they can't create new branches, they can't merge anything. They're there to consume information.
And participate in discussions, maybe.
Exactly, just discussions on existing issues.
Okay, that makes perfect sense. Purely participatory feedback. But what about the person who needs to actively manage the process of the project, the timeline, the triage, but still shouldn't be messing with the code?
That's the very distinct space occupied by the reporter. They inherit everything the guest can do, but their function shifts dramatically toward project administration and visibility.
That's so.
A reporter can create, view, and manage their own labels, which is huge for organization, and they can manage milestones.
So a reporter might use their label management to flag every incoming UI bug ticket with a standard tag.
Right. Or they might define the release prep milestone for a feature rollout. They're operating on metrics, on documentation, on the process flow.
Got it. So think of them as the project managers, the QA leads.
Or the documentation specialists.
Yeah.
Exactly. They need granular control over the data around the product, but they aren't tasked with touching the source code itself.
They need to track progress and flag things without introducing the risk of development changes.
You've got it.
Now we get to the actual builders,
Yeah.
the people whose hands are on the keyboard writing the features.
That brings us to the developer. This is the core contributor role. If you are writing code for a project, this is the access level you need.
Okay.
The developer's permissions are built around cloning the repository, creating new branches to work in isolation, and then pushing their commits to those branches. They are the engine of development.
Hold on a minute. If the developer is the one who wrote the feature, why can't they just merge it themselves? I mean, if I am a high-trust, experienced developer, isn't forcing me to wait for approval just redundant bureaucracy?
That's an excellent friction point, and the answer is security and governance, which is the precise reason the maintainer role exists. The maintainer inherits all developer permissions, but their true function is being the ultimate gatekeeper. They act as the final check on quality and policy.
So the quality assurance layer for the code base itself.
Precisely. The maintainer's key responsibility is governance. They can manage project settings, they can manage members within that specific project, and, most importantly, they have the sole permission to merge branches into the protected main branch.
They're the final sign-off.
They're the final sign-off before code goes live. It ensures standards are met and prevents accidental or malicious code from damaging the main product. The difference is, the developer writes the code, the maintainer approves, and deploys it.
So the maintainer holds the highest power in terms of the actual workflow. But we have one role left, the ultimate authority, the person who controls the container itself.
That's the owner. The owner operates one level above governance. They sit at the top of a group or subgroup structure and have ultimate administrative control over that container. This includes system-level actions that a maintainer just cannot perform.
What's an example of owner-level, high-consequence action that a maintainer can't touch?
So the owner handles things like transferring ownership of the group to another user, or, and this is the ultimate one, the ability to delete the entire group.
Wow.
That means wiping out every nested subgroup, every project, every repository, every issue, every single line of code contained within that structure. It's the ultimate delete button.
I once had a terrifying moment where a new owner, thinking they were archiving a single project, almost wiped out a major 3-year-old subgroup because they just misread the prompt.
Oh, no.
Yeah, you quickly realize the single biggest fear in this system is someone accidentally hitting that button. That's why you only grant owner access with extreme prejudice.
Absolutely. The owner wields structural power. The maintainer wields workflow power. It's a key distinction.
So we have this wonderfully efficient mechanism of downhill inheritance, the default setting. But like we said, if your structure is flawed, that efficiency can become a catastrophic security vulnerability.
Right.
This brings us to the practical challenge: precision and containment. How do we break that chain of inheritance when we need to?
This is where the rubber meets the road. If you're running a massive structure, how do you handle the exceptions? You need a mechanism to grant access locally without letting it just cascade everywhere.
Let's revisit our tricky scenario. We have a new team member. They need developer access to the mobile app project, right? They're coding a new feature.
Okay.
But crucially, our organization has that confidential internal finance project, and it lives under the same massive top-level parent group. We need to let them code the app, but they absolutely must not see the confidential financial data. Where do we add this user?
Well, if you just add them to the top-level parent group as a developer, they immediately inherit access to everything, including internal finance.
Which is exactly what we don't want.
So you have to step back and avoid the inheritance flow entirely. The mechanism of containment requires avoiding that common parent.
So you don't add them high up.
Exactly. Instead of adding them high up, you grant the access locally. You add the user directly to the mobile app subgroup, or if you want the tightest possible restriction, you add them directly to the mobile app project itself.
What's the key behavior change there? When they're added locally, what stops the permissions from spreading?
When a user is added locally at the project level, their permissions are entirely contained within that specific boundary. Their permissions do not jump sideways to other projects, and they do not jump up to the parent group. They are only a participant in the container to which they were explicitly added.
So local granting is the firebreak.
It's the firebreak in the cascading inheritance flow. That's a great way to put it.
So inheritance is always downhill, never uphill or sideways.
Yeah.
That's a critical distinction for you, the learner, to get.
And this leads to a slightly more advanced architectural point that managers really need to grasp. What happens if you grant a user two different roles in the structure?
Oh, interesting.
Say, I'm a guest at the main Acme Core group, which I inherited, but then I was explicitly added as a developer to just the mobile app project. Do my two roles conflict?
That sounds like a mess waiting to happen. Does the system, punish you by choosing the lower role, or do you get lockout?
No, the system is designed for utility. When a user has multiple grants of access, the system operates on the principle of maximum permission.
Maximum permission.
So if you're a guest via inheritance, but a developer via a local grant to a specific project, you receive the maximum set of permissions granted, in this case developer access, but only for that specific project.
That's a sophisticated layer of assurance. It means your local direct granting of a specific role will always override a lower inherited role.
Right. It ensures the user can actually do the job you hired them for at that specific project level.
And it must simplify the troubleshooting process a lot.
Massively. If a user can't do something, you check where they were last added, not just the top-level group.
This has been a true deep dive into user management. So, to recap the foundational knowledge for you, the listener, permissions flow downhill automatically from group to project.
For efficiency.
For efficiency and scaling. But if you need to restrict access, you grant the role locally at the project or subgroup level to break that cascade. And the specific role you grant, guest, reporter, developer, maintainer, or owner, that dictates exactly what you can do when you get there, with the system always granting the maximum set of permissions if there's a conflict.
Master those flows, and you master your system architecture.
And before we wrap, we discuss the incredible power held by that owner role. The power to delete an entire group, structure, and contents just gone forever.
Scary stuff.
It is. So for you, the listener, this knowledge should raise a really important question as you design your own project structures. When you're organizing access and ownership, how should those high-consequence roles be managed, not just for efficiency, but for redundancy?
A critical question.
What governance systems, what policies, or even technical measures do you need to put in place to protect against the ultimate delete button? To ensure that the critical structure itself remains safe, even if the ultimate owner makes a human error.
That's what separates a robust system from a brittle one.
We'll catch you next time for the next deep dive.